Okay, so the next section is chapter 4-4, has to do with complex numbers. Now, are they really difficult or things to handle? It's a name. Remember we had talked about real numbers at the beginning, and we said, well, if it's not a real number, what is it? Well, here it is. These are the imaginary numbers that we learn about, but we really can't see or count in our fingers and so on. So what is an imaginary number, right? So the imaginary unit that we're going to use is the letter I. So if you notice, it's kind of like we did a little cursive I. That's on purpose. We kind of do it with a little tail and kind of curve it like that, so that it doesn't look like the number 1 or an L, or to confuse it with something else. So what is I? Well, I is gonna equal to the square root of -1. So if I had ever asked you guys, what's the square root of -1? Well, you really can't give me an answer, right? Because what number times itself equals to -1, right? When you take the square root, so it doesn't exist. Now, another interesting property is, well, I squared is equal to -1. Now, how is that so? Well, think about it. If I ask you, what's the square root of 9? You would tell me 3. And I'd say, well, yes, but you're missing another number. And like, well, what numbers multiplied together give you a 9? 3 times 3 gives you 9, so that's correct. But what about -3 times -3? Doesn't that also give you a 9? So in Algebra 1, we primarily focused on the positive root, right? Now we're going to make a little more effort to look at all the possible roots, which includes the negatives. Well, so like I said, if I ask you to take the square root of 9 and you say the square root of 9 is 3, you would be correct. However, you would be missing another piece. And sorry, let me get my notes back. So in this case, -1, if you have the square root of -1 times the square root of -1, remember, it's those two numbers inside that pop out and become like the actual answer. So let's look at the pattern. So pure imaginary numbers are numbers in the form that look like this. So 6i, what does that mean? That's 6 times the square root of -1. So that would be the square root of -6. Here, it's -2 times I is really -2 times the square root of -1. Here, this is actually the square root of -3. You just, well, remember, we don't want that negative in here, so we pull it out as an I. I know it may sound a little confusing right now, but we're going to look at some more examples. All right, so what's I to the first power? Well, anything to the first power itself, right? So it's just I. But what is I to the second power? I to the second power is -1. I to the third power is a combination of this times this, isn't it? Because when you multiply exponents, you add them. So I to the first power times I to the second power, it's the 2 plus the 1 gives me the 3. So it's really just I times -1. So -1 times I is -I. What's I to the fourth? Isn't that just I to the second power squared? So I just square this number. -1 times -1 becomes +1. So I know it's going to take a little while to kind of look at that and kind of understand what's happening. But if you notice, there's a pattern. After I to the fourth power, I to the fifth power looks exactly like I to the first power. I to the sixth power looks like I squared. I to the seventh power looks like I to the third power, etc. So if you notice, this thing keeps repeating. So I to the ninth is going to come back and look exactly like this. I to the 10th, I to the 11th, I to the 12th, etc. So you can find a pattern. So hopefully if I asked you, hey, what's I to the 57? Then you could, let's see, well, every 4, there's a repeating pattern. So let's see if you can get there some way to try to figure out what your answer would be. So we also have this square root property that we're going to be dealing with. And if you noticed, it's useful when you have quadratic equations that you notice that are perfect squares. Here, so for example, I know what the square root of 64 is. That's 8, right? I know what the square root of 100 is. That's 10. So I'm kind of getting the hint then I'm probably going to just have to take the square root and I can solve it real quick. So how do you solve for x? Well, to solve for x here, wouldn't you have to move the 64 over this way? So here it is. And so what do I get? Well, I get x squared is equal to negative 64. Oh, there we go. Negative 64. I know how to take the square root of 64, but negative 64? Yikes, that's going to be a little interesting. Well, this is what you're going to do. You're going to take the square root of both sides, right? Don't you end up with a square root of negative 64? This is quite simple. Take the square root of the part that you know. I know how to take the square root of 64. That's 8. But remember, it can be positive 8 or negative 8 because negative 8 times negative 8 was 64. Once you get that part solved, then I'm dealing with this negative 1 that's left over because this is like negative 1 times 64. I broke it up in those pieces. So what's the square root of negative 1? I. So that's how you take care of that. Let's look at the next example. Solve for x. All right, so then I need to get the x here by itself. So I kind of did 2 steps here. I didn't show the details, but let's just do it. So if I have 4x squared, I have the positive 100. I need to move the 100 over here, right? So it becomes a negative 100. So I end up with 4x squared equals negative 100. But I don't want 4x squared. I want x squared by itself. Divide this side by 4. Divide this side by 4. What do you get? Well, what's 100 divided by 4? 25. But remember, I had moved the 100 over here, so it was negative. So now I have x squared is equal to negative 25. Okay, so now I can continue to solve for x. How do you solve for x? Divide, or actually take the square root of both sides. So the square root of x squared is just the x, right? And that is equal to, okay, here we go, square root of a negative 25. I know how to take the square root of 25. It's 5 times 5 or negative 5 times negative 5. So that's what this plus or minus, this is like or. It's plus or minus. It's positive 5 times positive 5 or negative 5 times negative 5 that gives you that 25, right? So the square root of 25 is 5 or negative 5. And I left over the negative 1 in here because this is like negative 1 times 25. The square root of the negative 1, I. So anytime you have taking the square root of a negative number, just think of bringing down the I. So that's a complex number. It's any number that can be written in the form a plus bi, where a and b are actual numbers like 5, 10, 100, negative 7, etc. And I is the imaginary part because it's the square root of negative 1. Because I don't know what that is. I can't see that. So you might also get some things that you're going to multiply called complex conjugates. Usually a conjugate is like, the opposite. So 2 complex numbers, say a plus bi and a minus bi, then those are called complex conjugates. And you'll probably see that in some of the sample problems you're going to be working with. So now let's go on to the packet. So now let's look at your packet. And this is a section with 4-4 complex numbers. And so if you'll notice here, you have, again, some vocabulary. But the good thing is here it shows you how to solve these particular problems that we've been talking about. So kind of review and look at the ways that they use to solve these. So if you're trying to multiply them, notice how I times I, you get I squared, but we already know how much I squared is. Look at the notes. It becomes a negative 1. And so now you can multiply the real part, which is a negative 3 times 2. You get negative 6 times that negative 1. So the answer is actually 6. So that's the only thing here that you need to just be careful with. Anytime I gets multiplied, use the rules that I gave you about I squared, I to the third power, etc. So kind of review those examples, try to do them on your own. And then now it's asking you about some properties that you can use on these two. So here you'll see like the commutative and associative properties, just how they work out and stuff. So it kind of works the same as when we did those earlier on with the property for addition and subtraction and all that stuff. So then some more simplifying things you can do. to try to answer these type of questions. Then you have the practice problem. So it continues. They ask you to simplify roots and so on and so forth. Well, let's just look at an example. So let me work one of these out for you. So let's look at the square root of 72. So if you notice this, if you want to break it up into the pieces that you can do, that's perfectly okay. That's what I usually do. I know that this is really like saying the square root of -1 times the square root of 9 times the square root of 9 times 8 is 72. So something like that. But I could probably find a larger root of 72. Let's see, does 16 go into 72 evenly? So I guess I'll find out in just a little bit once I do my my calculations. Okay, so the square root of -1, I already know what that is. Isn't that just the letter I? So I'm already gonna write that down. I already know the square root of 9. Isn't that 3? Now, this is where I have a little problem still. So this is still multiply and multiply. The square root of 8, I completely forgot that I could actually break that down into the square root of 4 times the square root of 2. Would you agree with me? Because what's 4 times 2? That gives me 8. So I can break that piece down even more because I already know the square root of 2 is 2. And I'm still multiplying with all this other stuff. So there's a times here. Now I didn't have to put that dot, but I put it just so you can see that it's multiplied. So when you're working with these, you can always multiply numbers together because they're real numbers. So let's do that. So in the final answer, I get 3 times 2, that's 6, the I, and times the square root of 2. So that would be final answer for number 1. Now for number 4, use a FOIL method. This times this, etc. But don't forget, when you end up with I times I, well, it's a positive I times negative I, you get a negative I squared. I squared you need to change into something else. So it continues with solving the equations, like I showed you an example in solving for x, move stuff, divide, and see what kind of x's you get there. So then it gets into more complex number operations and so on. So, go ahead and read the notes and, of course, use the properties that they give you to simplify. And then, of course, go over the examples. How do you simplify these problems? Or, here, be careful with the operations. Here it's plus, you're adding. Here you're multiplying. So just be a little careful when you do that because it can get a little bit complicated. So let me do one with addition. Remember, it's this stuff plus this stuff. I'm not doing FOIL because I'm not multiplying, I'm adding. So I take the real part, 6 minus 4. 6 minus 4, I get 2. And then the imaginary part is this right here. So it's 2i's minus 3i. So there I get negative I. So this would be the final answer, 2 minus I. And yeah, I know some of you are like, well, Miss, why are you, that's my I. This is kind of a cursive I. So it kind of has like a little tail and then a loop. That's done on purpose because if you notice, this can look like, I don't know, a letter L, the number 1. So we always do kind of like this little curve. It's almost like if you notice sometimes when I draw the letter Z, I write a little stick in there because, 2 is at a 2 is at a Z, just to make it simpler letters, kind of have a little line through them. Or you'll see me sometimes, my number 7, I put a little line through that. So most of us that have studied advanced math, you'll see, will do stuff like that. And of course, and there you go. So you have a lot of practice problems. Notice how they go really crazy on the I to the 89th power. Remember I told you there's a pattern. If you saw 1, 2, 3, 4 are the same, and then 5 is like I to the first power. I to the 6 is like I to the second power, etc. So see if you can find that pattern to, because you don't want to I times I times I 89 times, you'll never finish. Try to look for that pattern, see if you can kind of say, oh, wait a minute, you know what, odd number ones or every fourth one, or to get to 89, it would be like me skipping like this. Try to find that pattern and see how it goes. And then, of course, they're asking you to solve these. So let me go ahead and maybe do one for you. So something like 23. If you notice, if I wanted to solve it, I'm going to write it up here so I can do it for you. I'm going to move the 10 already. So there should just be a minus 10 here. So equal to negative 10. And I need to solve for m. So I'm dividing both sides by 2. M squared should equal to negative 5. So yay, I'm almost done. When you solve something, you bring it down to like reduce it to the most minimal numbers that you can. Well, if you notice here, I need to reduce my m squared. Sorry, I need a little sip of coffee. And so I take the square root of both sides. So if I take the square root of this, take the square root of this, square root of m squared is easy. That's the m. This is equal to, well, remember, you've got two pieces. I've got the square root of negative 1, and I've got the square 5, because 5 times negative 1 is the negative 5. This I know how to do now. It's the letter I. This is just going to stay square root of 5 because, we don't, you don't have to turn it into a decimal. You can grab a calculator and all that, but that's fine. So if you give the final answer as m is equal to, you always put the real part first and then the imaginary part. So this would be your final answer for number 23. And it looks like that gets us to the end of the second 6 weeks or so. So we'll start the next section soon.